All right, welcome everybody. So the next skill is an extension of the skill we just talked about. We're going to be moving a point under transformation, but the difference is that this time it's going to be a compound transformation. And so there's two skills we have to kind of evaluate. First is, can you read the rule? And then second, can you apply the rule? I personally think moving just a point around is a little bit more difficult than almost moving a triangle around, just because you can't really see the shape move as well as you can see like the point move, right? So we provided a graph again. Like on the test, you may or may not have a graph. And so it's important to note that even though we're going to use a graph to help us kind of visualize it, we can also do this work without the graph. Right, so let's get into it. So first thing on the rule, let's remember that the way the composite rule works is that whatever is listed second will actually happen first. Okay, so we're first going to execute that transformation, and then we'll execute this transformation. Right? And so kind of like tearing this transformation apart, we should recognize that we have a subscripted line. The letter, even though the R kind of gives it away, it's really about this line. And so we're going to reflect in this case over the y-axis, which another way to think about that is that's going to flip horizontally, okay, or side to side. After we execute that, we'll take whatever that result is of that reflection, and we're going to perform another reflection, this time over the x-axis. Okay, and since the x-axis runs side to side, we're going to be flipping up and down or vertically. All right, and so before we even take a step to actually perform this compound transformation, we should have a nice visual about what's going to happen to this point. First, it's going to flip horizontally over the axis to the right, and then it's going to flip vertically over the x-axis to the bottom. And so it should probably end up kind of somewhere down here. Like that'd be my guess. It'd end up in there because it's going to kind of flip to this side, and it's going to flip down to here. We shouldn't just rest on the guess, so we should go ahead and execute it. So if we take this point A and we reflect it over the line of symmetry, let me get a better line of symmetry for you guys. Let's go, there we go, over this axis first. Please note that that should be the perpendicular bisector of our mapping line. And so if we take point, I'm sure I meant to be point A. We'll just ignore that little prime there. So if we take this distance 1, 2, 3, 4, 5 to the axis at a right angle, it should travel 1, 2, 3, 4, 5 away from the axis, and that should be our A prime. We can certainly like count out what the coordinate point is going to be, but since all we're doing is changing the x, we can guess it should be at 5, 7. Okay, and now we got to flip over the other line of symmetry. This time the x-axis. Okay, and so we're going to again execute a flip, and so it's got to be another perpendicular bisector. So we're going to count 1, 2, 3, 4, 5, 6, 7 to the axis, and then 1, 2, 3, 5, 6, 7 away from the axis. That's going to be your A double prime. Again, we could simply count out to find the coordinates, but since we know we start at 5, 7, and then we're just flipping to the other side of the y-axis, we're going to keep the 5, and then we're going to change to a -7. And so A being 5, -7 is the answer we're looking for. Okay? And so using that as a template, we can jump into number 2. Oh no. There's back. Okay, and we're going to kind of take the same steps. And so first we should definitely figure out what transformation we're executing first. And again, remember, kind of the backwards rule is that first we're going to do this thing. We know it's going to be a reflection. Which means we're going to flip this thing over the x-axis, so we're going to be flipping it up, down, or flipping it vertical. All right, second thing. Okay, looks like we have a translation because we're given a vector. So this is going to be the second thing we do. So a translation along the vector -12, 7 vector. So that means we're going to change our x and y by subtracting 12 from our x and then adding 7 to our y's. which means we're going to slide left 12 and then up 7. All right. So again, before we even start, we should kind of take note and in our heads kind of figure out where this is going to end up. We're first going to flip over the x-axis, and then we're going to slide like up and to the left. And so my guess is it's probably going to end up somewhere in this quadrant. Again, just a guess, but that's where it's going to kind of be, I think. Let's get to the execution step. Okay? So first we need a line of symmetry. Okay, that's going to be the x-axis, and so I'll kind of fill that in green. Okay, and so to reflect this, we're going to go 1, 2, 3, 4 to the axis, and then 1, 2, 3, 4 away from the axis. Okay, so that means our A prime point should end up right here. That's going to be same x value, flipped y values, and so that should be at 8, -4. Okay, and then we have to move it left and then up, 12 and then 7. I think we can just count this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then up 1, 2, 3, 4. Oh, lost it. 1, 2, 3, 4, 6, 7. And that means our A double prime point should be at 1, 2, 3, 4, 1, 2, 3. So -4, 3. Okay. Now we probably could have predicted the final translation without actually having to have done it. Because we know that we were at 8, -4. If we take 8 subtract 12, we're going to be at 4, or -4, excuse me. And if we take 4 add 7, we're at +3. And so my point being, you can kind of do this by the coordinates, or you could do this by the graph. It's equally good. All right, so the last one, under this kind of double transformation on a point business, looks like we have to do a double translation. So our first one, there's no mystery now. This is our first one, so it's going to be a translation. Okay, so the xy should go to x plus 14, y plus 5, which means we're going to slide left 14 and then up 5. And so it's kind of going in like this direction. And then for our last translation, our second translation, okay, we're going to take the xy, and we're going to go x -3 and then y -10, which means we're going to slide, in this case, left 3, and then we're going to do down 10. So left 3, down 10, which means that we're going to kind of slide. Yeah, so that means we're going to then kind of slide back. And so we're going to kind of take this point, move it to the right and up, and then move it kind of back down and left. And so I'm not quite sure exactly where it's going to end up. Probably somewhere towards the middle would be my guess, but let's go ahead and map route. With translations especially, you can use a point analysis, meaning that you can take the x plus 14, y plus 5, and just get where it's going to get. And so like what I mean is, if we're going to do like xy, x plus 14, y plus 5, we can feed in the current point, -6, 3. That's our A. Okay, so that's going to be -6 plus 14, and then 3 plus 5. So that should be end up at 8, 8. Okay, or you can just count it out. I mean, we can literally just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then a 5, 1, 2, 3, 4, 5. Now, if we did this right, 8 prime should be the same thing that we predicted at 8, 8. And if you count that out, it is indeed going to be at 8, 8. And that just reveals there are two ways to address like this type of transformation, or really any transformations. You can do it by calculation, or you can do it by counting, right? And so we can do the same kind of analysis with our second transformation. Okay, and so if we take the current 8 prime point, which is 8, 8, and feed into our rule, 8 minus 3 and then 8 minus 10, I know that a double prime then has to be at 5, -2. Kind of right in the middle like I was saying before. Or we can just count it out. So we have to go left 3, so 1, 2, 3, and then down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so our A double prime point shall be here. Okay, now we can check the coordinates. It is over 5 down 2. Okay. Which means, again, confirming that you can do this by hand, or you can 100% do it by some calculation, or really a mixture of the two. Right? And so just like the previous skill where we're kind of flipping a point like by translation or reflection, be prepared to do that twice, like in a compound. So like do a reflection, then a flip, or then a translate, or translate, and then reflection, two reflections, two translates. We can do a ton of different stuff here, guys, so just please be prepared. All right, that's it for this topic. I'll see you on the next page.